Answers to quiz 2. Oh, just for Nick. Sadly, he's not here. A truck parked on a downslope slips its brakes and starts to coast downhill from rest. Oh, that's one of those key words I'll mentally underline. Yeah, you know, I'll actually underline that. Because that tells me that VI is 0. Oh, and I see that A is 0.7. And in part A, they mention that time equals 6. And they want me to find V final. Okay, that's kind of nice. I think I can go V final equals V initial plus AT. I think I can go 0 plus 0.7 times 6, and I think you'll get 4.2 meters per second. If you got that, you get 2 out of 2. Otherwise, the way I usually mark these is I give 1 mark if I see the correct equation, and then 1 mark for the answer, because I think half the battle is being able to figure out how you can find it. Second half of the battle is actually finding it. How far will the truck coast? Well, now I think I can go D equals VIT plus a half AT squared. Cole, why can't I do that? Why can I do that? No, why can I cross out the VI is equal to 0, which it's still a quadratic, but thankfully, because that gets rid of the second t, it means I can deal with this equation without pulling out the quadratic formula and all that fancy schmancy stuff, which you'll be learning about this year. Have you guys done, any of you done the quadratic formula already this year?
Yeah, we're starting it.
Just starting it, okay. So you'll find out why shortly. Anyhow, this is going to be 0.5 times 0.7 times 6 squared. Can I do this in my head? 36. Half of 36 is 18. 0.7 times 18 is going to be, well, 10 times 7.7. 7 plus 5.6. 12.6? No? Yes? Yeah? Meters. If you went to 2 sig figs, which technically you should, 13 meters. Again, same idea. Doug, 1 mark for the correct formula, 1 mark for the answer. Question 2. Jacob, how many marks is question 2 worth?
3.
How much you want to bet maybe it's a 2-step? Maybe I'm going to have to find something and then use that to find something. See how I figured that out? I'm a good test writer. I tend to notice, hey, what's the question worth? What's it out of? Hey, if it's only worth 1 mark, that either means it's really easy or it's so ridiculously hard that Mr. Duke didn't want to make it worth as many marks as it should have been because he knew most kids would get it wrong. But that doesn't happen very often. Usually it means it's pretty straightforward. A motorbike accelerates at a constant rate from a standing start. Okay, that's probably going to be important because VI is 0. After 1.8 seconds, it's traveling 7. Oh, is that a VF? Oh, wait a minute, keep reading. How much time will have elapsed starting from rest before the bike is moving with a velocity of 16 meters per second? I think there's kind of a before and after. I think what they want me to find is total time when V initial is 0 and when V final is 16. The problem is right now I don't have enough. I need something else. Greg, what I need to do is I need to find the acceleration. And if I can find the acceleration, then I can find that. I'm going to go walking back over to here where VI is 0. Well, I hit 7 meters per second after 1.8 seconds. I should be able to find the acceleration from that, and then I'll just assume that it continues accelerating at that same rate. Oh, it says at a constant rate, doesn't it? So I don't even have to assume. I think the acceleration is going to be V final minus V initial all over t. It's going to be 7 divided by 1.8. 7 minus 0, which is 7. It's going to be 7 divided by 1.8, 3.88888888. I'll go 3.889. I won't round off yet because I won't do sig figs yet because I'm going to use this answer. Come on, decimal point. And I'm going to plug that right for here. What am I trying to find here? Time. I think time is going to be V final minus V initial all over A. Yoink. It's going to be 16 minus 0 all over 3.888888888888888. Oh heck, 4.11? Is it 4.11? 4.1 seconds. If you got that right, you get 3 out of 3. Otherwise, if I was marking this, I would give you 1 mark if I saw that you'd calculated the acceleration correctly, if I saw that 3.89 or 3.88888 repeating or something like that. I would then probably give you 1 mark if I saw, oh, you clued in we're finding time, and I would give you 1 mark for the answer. Number 3, an aircraft starts from rest. Oh, okay, Mr. Dewick, I'll mentally underline that word. That's key. Accelerates at a constant rate. Okay, once its acceleration. How good am I? Now, this is a quiz. I shouldn't try and see how good I am, but I'm going to show off and see. I'm going to see, Jordan, if I can go straight to the formula and solve without actually deficking, without actually listing my data. On a test or a quiz, I always would list my data, but I'm pressed for time a little bit today. So, race, I'm going to say they want A. Do you know how I knew to use that one? I saw they mentioned time, and I couldn't see a meter's distance anywhere. So I said, well, the only one that has A and doesn't have D in it is that one. V final, 12. V initial, 0. Oh, no, not 12, Mr. Dewick. That's time. Look at your units, Mr. Dewick. V final, Enzo just bursting to say 48 because he wants to get something right for a change. Absolutely. 48 take away 0. Enzo is what? Nice. See, I can do 0 subtraction. And 48 divided by 12?
4.
Now, if you wrote 4 meters per second, that's perfectly acceptable, and I'll mark that correct. Technically, they're going to 3 sig figs. I should technically go 4.00, shouldn't I, if you really, really wanted to be fussy. 2 marks each, standard. 1 mark for the equation, 1 mark for the answer. How fast is the plane moving after 16 seconds? Oh, different amount of time. Now they want V final, which is going to be V initial plus AT. Could I find V final without using the acceleration? Yeah, I guess I could go. I could use this one where VI is 0, V final is, and I could oh no, I don't have the distance, do I? Never mind. You know what? I'm out of luck. I can't use that one. I have to use my answer from A in order to do B. That's fine. I'm good enough now. I think I can justify that. It's going to be 0 plus 4 times 16. Is the answer 64.0 meters per second? I think so. How far down the runway? Now they have a distance question. I think I can go D equals VIT plus a half AT squared. Cole, why can I do that? Why can I do that? Woohoo! So according to you, sir, it's going to be 0.5 times A, which is 4, times T squared. I think I can do this in my head. 15 squared is 225. Half of 4 is 2, so it's really 2 times 225. It's 450, yeah? To 3 sig figs, technically I should put a dot there. Whatever. So 2 marks for each of those. 1 mark for the equation, 1 mark for the answer. Turn the page. Number 4, what is the rate of acceleration of a mountain bike which slows down from 15 meters per second to 10 meters per second in a time of 3.25 seconds? Hey, what does that tell me my answer is going to look like? Yeah, I'm expecting a negative. If I don't, I've zigged, right? What are they asking me to find here, Matt? How about A equals V final minus V initial all over T? Final, 10, initial, 15, time, 3.25, bracket, 10 minus 15, close bracket, divided by 3.25. Do you get negative 1.54? meters per second squared. Oh, also, if your units are missing or wrong, that's a half mark off of the way I mark these on your test. You know, I think, Janaya, a good habit before you hand stuff a test in, check your units. And in Physics 12, check your sig figs, because then I'm a bit fussier, but in Physics 11, I'm not. Although you can check your sig figs if you want to, because you're a nerd. But you always, before you hand it in, go through the written section, make sure you got units on every single answer at the very, very end. Number 5, law enforcement. A police officer traveling at 16.7 meters per second, 60 kilometers an hour, spots a speeder ahead. So she accelerates her vehicle at a steady rate of 3.44 meters per second squared for 5 seconds. How fast was she traveling after 5 seconds? This looks like a job for V final, which is V initial plus AT, which is 16.7 plus 3.44 times 5. Can I do this one in my head? Well, 3.44 times 5. You guys know the trick to multiply by 5 when it's a decimal? Times by 10 and divide by 2. It's going to be 34.4 divided by 2. 34 divided by 2 is 17. 17.2 plus 16.7, 17.2. Is the answer 33.9? Woo, Mr. Dewick! Come on a minute. Some of you are a little jealous. How far? I can use this. By the way, if this was a test, Taylor, and I finished early, I could also go using my acceleration answer, or sorry, my V final answer from part A. And if I get the same answer as this, then not only do I know B is right, I know part A is right too. Right? So we are at the stage where I'm showing you the quickest probably, or the cleanest way to get there. But Jordan, there's often more than one approach now. VI, 16.7. T, 5 plus a half. A T squared. All right, Mr. Duke, try that one in your head. Well, 16.7 times 5 is going to be 167 divided by 2, which is going to be 50 plus 30 is 80 plus 67 divided by 2, Mr. Duke. What's 67 divided by 2? It's going to be 33.5, 83.5 plus 20. This is about where I go to my calculator. Especially because this is a quiz and I want to make sure I get this right. $126.5? Technically 127 to 3 sig figs. Whatever. Units, meters. Okay. Number 6, a motorbike rider traveling 20 meters per second, about 70 kilometers an hour, so roughly traveling on the Lougheed Highway, collides with a haystack and is brought to rest in a distance of 5.7 meters. 5.7 meters, what's that, from about me to Joel-ish? About 5.7 meters? Yeah, I'm just 1, 2, maybe a little further, maybe closer to where Jake is. Yeah. What's their average acceleration? I'm trying to visualize this because I'm kind of curious if this person would survive. Let's see. Oh, I need to use the VF squared minus VI squared all over 2D. I need to use that one, don't I? Don't forget the squareds. It's going to be 0 squared minus 20 squared all over 2 times 5.7. More than one number on the top, Kelly. More than one number on the bottom. Brackets, 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 please. Bracket 0 squared. I guess I could have just typed 0 instead of 0 squared, but whatever. close bracket divided by bracket, 2 times 5.7. Do you get negative 35.1? Is that survivable? Well, if I divide that by 9.8, that will tell me how many g forces, except it's not g forces, it's g accelerations. But in English, Aaron, they call it g forces out in the real world. How many g's, I'll say that, this person would take? 3.6. That's very survivable. In fact, on the elevator, you kiss up to about 3.2 g's. So the haystack did its job. It lengthened the acceleration out long enough that this person survived just fine. Yeah?
I got one decimal place off that, 35.1, negative 35.1. That would mean he slows down to what?
He's slowing down at negative 3.6 Gs, which is survivable. He'd have some scrapes, and if he hit at the wrong angle, he might break a bone. But I'll be honest, 3.5 Gs, I've done that on amusement park rides all the time. Yeah.
Wouldn't the correct number of sig figs be 2?
Probably. I covered it up. Let me see here. Yeah. So negative 35. That's the disadvantage with my little tablet system, is I can't see what's underneath my little calculator sitting there. I need a bigger screen. If they made a nice big tablet, that'd be cool, but for cheap. Hey, any lawyering with me? Now is the time. Otherwise, give yourself a lovely score at the top out of, count 'em, 21. I also gave you a second handout. It was called Acceleration and Slope. It was, hello, Mr. Duick, where are you? Right there, this thing. Can you find this puppy, please? Or, well, I'm going to ask if you have any questions from this sheet here. This is due by the end of today as well, but I'll take any questions that you had from it. Someone did point out for number 4, was it Doug, I think, who said, hey, Mr. Duick, number 4, and by the way, number 4, I was just making up numbers, but they said, if you throw it out of a tall building, wouldn't the acceleration be negative 9.8? And wouldn't the VI like be negative 5 or something? Was it you that pointed that out to me? Yeah. In all honesty, yes and no. You're going to find sometimes it's mathematically nicer to let down be positive. In fact, when we do some questions and forces in our next unit, and certainly Physics 12, we'll have some stuff moving upwards, positive, but it's hooked onto a rope pulling something to the left, negative. And we're going to say, well, which way is positive, which way is negative? And we're going to decide ahead of time which way makes the math easier. That's going to be positive, which is not the best physics approach. Actually, it is a good physics approach because, you know what? Everything is relative. Down, up, whatever. The trend is, when in doubt, let up be positive and to the right be positive. But that's actually sometimes way more convenient to go the other way around. Anyhow, were there anyone here that you were going, Mr. Duick, I have no idea how to interpret these graphs? Completely lost. The answers were attached there. Now is your chance to ask. Going once. Going twice. So later on in class, if you want to hand that in, but not right now this moment, because the third thing that I gave you was the, oops, I forgot to photocopy the lesson properly lesson. I haven't done that for a while. I photocopied the wrong handout. And I gave you questions on relative velocity. I gave you 2 train questions and then 4 generic ones. Any of these you want me to go over? So first of all, from the train questions, number 1 and number 2, any of those 2 that you would like me to do? This one, number 2? Okay. How long does it take for these 2 trains to completely pass each other? My thinking when I approach these, here's what I notice. Is there more than one object? Say yes. Is there more than one object moving? Say yes. Are they at different speeds? This is a job for relative velocity. This is the time you want to pretend one of them is standing still and the other one is moving. Okay? So I would say to myself, for these to pass, this back end has to pass that back end. That's what we mean by passing. What's the total distance we're going to travel in order to do that? I think that plus that plus that. So how far? 460? 260, 380, 4, yep. And I'm going to let one of these trains be standing still, so I'm going to say the relative velocity. What's the relative velocity of these two trains? 16, because they're coming towards each other, right? Now I can find t, which is going to be distance divided by v, because no acceleration. So 460 divided by 16, whatever the heck that is. Is that okay? By the way, most common mistake, kids aren't sure. Is it 16 meters per second or is it 4 coming towards each other? That's like they're really speeding up towards each other. That's going to be a bigger answer. Yeah, 16, 16, 16. Hey, how about on this page? Any others? Any of these? Yes? Love to do 3. I like number 3. I like number 3. I like number 3. Number 3 is a nice question. Okay. Why did I say that, Doug? Did you hear me say it's going to be on the test? You're just one of those students that tends to notice when a teacher emphasizes stuff? No, it's a good study. Good study habits. I'm going to gulp. Okay? Police. We'll do them in red. We'll put the criminals in black. How far? Sure. What else have they told us? They've told us that we have a time limit. So I'm going to make a little note here. Our displacement seems to be the distance that we're talking about is 120 meters. How much time do we have? Now here's what I'm going to do. I know that the 170 kilometers per hour, I'll change that to like meters per second later on. Or you know what, I'll change my meters per second back to kilometers per hour later on. I'm going to get an answer in meters per second. I'm going to temporarily pretend that the criminals are standing still. I'm going to say if they were standing still, how long would it take the police car, how fast would the police car have to be traveling in order to cover 10 seconds, 120 meters? I think I'm going to say the relative velocity. So this is different. Instead of me knowing the relative velocity and using that to find like a time, I'm going to use time to find what the relative velocity has to be. And that's going to be, well, let's see. We have distance equals vt, no, a half at squared because no acceleration. So it's going to be distance divided by time. Oh, yeah, meters per second. That makes sense. It's going to be 120 divided by 10. If they're standing still, they have to travel at 12 meters per second. How many kilometers per hour is that? 43.2? But this is the relative velocity. What it's really saying is the cops have to be going 43.2 kilometers per hour relative to the bad guys. Faster than the bad guys. I think 213.2 kilometers per hour. Okay, nice little question there. Any others? Figured so. Is that okay, Doug? You're good for a 3?
Yes.
Do you mind, can I erase all this? Because I want to do number 5 right here too, so it's also in front of me. Lasso. All gone. No, I still needed that, Mr. Dewick. Well, too bad. Number 5. We have Nathan and Jill. Here's Nathan, Amanda. Here's Jill. How far apart is their love? 140 kilometers. Is there more than one object moving here? Yes. Are they traveling at different speeds? Yes. This is a job for relative velocity. I'm I know it says that Nathan starts out at 90 kilometers per hour and Jill leaves at 105. I'm going to just use the relative velocity, and I'm going to say that's the same as though one of them was standing still and the other person was traveling at 195 kilometers per hour. Is that okay? Now, I was going to change this to meters per second, but I noticed my distance is also in kilometers. You know what? Let's do this in kilometers. Time is going to be distance divided by velocity. Again, I'm using d equals VIT plus a half AT squared. No a, so no a half AT squared. It's VT. Oh, and since there's no acceleration, VI is just V. So I divided by time, or divided by V to get the time by itself. The relative velocity is 195. How far will they travel, combined distance, the two of them, till they meet? 140. Now, they meet there, or there, or there. I don't care where they meet. I just know that if you add up how far Nathan traveled and how far Jill traveled, they're traveling 140 kilometers grand total, because that's where they're going to meet. What's the time? And this is in hours now, mind you, Amanda, because we kept it in kilometers per hour. What's the time in hours if I go 140 divided by 195? I get 0.718 hours, which is kind of a weird. Or if you really want to, Amanda, times 3,600, 2,584.6 seconds. Or 43 minutes, 43.1 minutes. That many hours. That's not, so the question said when, after about 43 minutes. Where? Let's look at Nathan. What's Nathan's velocity? His actual velocity, according to this question. 90. Sorry? 90. And that's kilometers per hour. And he's going to travel at 0.718 hours. By the way, can you see I'm going VT to find his distance? How far does Nathan travel in that time? 64.6 kilometers from Calgary. 64.6 kilometers from Calgary. I noticed in the answer key it gave the answer from Banff. Well, if the total distance is 140 and we're 64.6 from Calgary, subtract and you'll find, hey, we are 75.4 from Banff. So nice little relative velocity question. Any others from the homework? So later on today, if you can hand in the acceleration and slope worksheet and the relative velocity handout as well. I have, count them, 4 things to give you. So today I've given you, count them, 4 handouts. The very first one says acceleration quiz number 3. It's what it says, acceleration quiz number 3. Oh, because it's dealing mostly with free fall, when my friend was typing up the equations, instead of putting a letter A in, he put a letter G in for most of your accelerations because it's free fall. But G is what we use as our symbol for negative 9.8 meters per second squared, right? So you can try that one. Then I gave you unit 4 quiz number 4, this one here. You need to notice for this quiz that there is a back page. Can all of you notice that for this quiz, Joel? Can all of you notice that for this quiz, Joel? Can all of you notice that for this quiz there's a back page? Oh, and that back page looks strangely familiar, strangely similar to question 3 from the homework. I think I see a police car chase. Cool. So it's got some relative velocity, it's got a little frequency, holy smokes, and I didn't put any equations on here. This is for you to think about which ones you're going to use. Remember, you are allowed to bring in the yellow formula sheet to your test. Then I gave you the unit review. Looks like this. Yoink. Yes? We're going to cross out some of these questions, so get it out. You can cross out number 1 and number 4. if you take a look at number 12, I just want to talk about number 12. I don't want to cross it off because the answer is so staggering. Anyways, it says if an electron inside a TV tube, TVs used to have tubes. How many of you have a computer monitor that's more than 3 or 4 years old? Or the old iMacs, the color ones, the color plastic ones that were like blue or pink. If you look at an old style TV monitor from the side that has that big bulge in the back, that used to be a TV tube. It used to be an electron gun, a cathode ray tube, and it was great because we could actually teach you how they worked in Physics 12. Sadly, the technology for plasma and LCD screens is way beyond Physics 12. But anyways, what this is talking about is the old style TVs. It says, if an electron inside a TV tube accelerates in a space of 5 centimeters, 5 what? Better change that to meters. From rest to 1/10 of c. Say what? Where c is the speed of light, 3.0 times 10 to the 8th. I think 1/10 of c, v final, will be 3.0 times 10 to the 7th. 1/10 of 3.0 times 10 to the 8th. Calculate the acceleration. It's stunning. Electrons accelerate really, 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 really fast. That's why you don't see them move. You just assume they get there right away. Turn the page. You can nuke number 14, yoink. And you can nuke number 17, yoink. That unit review is due the day of the test. When's your test, Joel? Thursday, a week from today. When's your test, Joel? Thursday, a week from today. The very final handout that I gave you can start to think about. This is what we're going to be working on next week, Friday. It says, balloon car racers, your objectives are to create a balloon-powered race car that gets you maximum velocity, acceleration, and displacement. And you're going to be using some of your acceleration equations along the way to analyze your results. What are the materials? Well, balloons. I will supply you with some balloons, but if you want to buy your own personalized balloons, if you want to get the long tubular kind, as long as it's a balloon, it's legal. So you buy your own. Various materials to construct the racers. What are the rules? Your car must be powered only by balloons, no external other sources of motor power. No other sources of power. You can build the car out of anything, except here is the one restriction. Well, sorry, 2 restrictions. It must have at least 2 wheels. And wheels are defined as anything that is circular and revolves. The wheels cannot be wheels from a toy car. In other words, the wheels can't have meant to be used as wheels when they were first created. Use something that you can use as wheels that isn't wheels. Got me? That's the restriction. The car may not leave the ground. One year, about 3 years ago, I had a kid design a paper airplane, and then he cut out 4 wheels out of paper because they were circular and just glued them onto the side. Those are wheels, Mr. Duick. Oh, and then he had a little, no, it has to be on the ground. Nice try. And the car must be capable of traveling at least 2 meters. We're going to be having 2 contests. One is fastest to cover 2 meters. We'll be doing that one in the class. We'll just set out 2 meters on a piece of tape. The second contest will be who can travel the longest. We'll be doing that in the hallway down here to our left, to my left, the cafeteria hallway. I have once had a car make it the entire length of the hallway on one balloon. It was quite impressive. They'd done some very good engineering. Procedures, you'll bring in materials from home and you'll assemble your car in class. That's what you'll be working on Tuesday after I finish marking the 2 take-home quizzes. On race day, Friday of next week, you'll set up a track in our classroom. We'll race against other classmates. Groups can be of 1 or 2 or 3, no bigger than a group of 3. You can build one by yourself if you want to, a group of 1, a group of 2, or a group of 3. It says awards will be given for the fastest car, except it's not 5 meters, it's 2 meters, and the furthest distance traveled. Any questions there? So what are you working on today? Well, if you haven't finished off the relative velocity homework and the acceleration and slope sheet, I want those today. Otherwise, you can work on, Joel, my friend, in class, quiz number 3. Quiz number 4. And then you can start the unit review.